these sirtuins are regulated by something called NAD, nicotinamide adenine dinucleotide.
That's it.
So plus. But that is something that actually those levels rise during a fasted state.
They sure do, right. And in response to exercise as well. And so the reason NAD is so exciting compared to the 1980s when we thought it was just a housekeeping molecule for reactions is that the levels of NAD go up and down depending on not just what you eat, but whether you're exercising and even what time of day it is. So during the day, your NAD levels will rise, and then you eat a big meal, and they'll go down again. And we think it's one of the reasons you also get jet lag, is your NAD cycles are out of whack.
Is it on a circadian rhythm, or is it completely regulated by meal intake?
It's a combination. It will be going up and down with circadian rhythms mostly, but you can adjust it within
What
that.
about macronutrient composition? Like if you eat more high fat versus carbohydrate?
Yeah, no one knows. That would be a good experiment. The circadian field hasn't looked at nutrition as far as I'm aware. But what I can tell you anecdotally is that if I raise my NAD levels when I'm traveling, I feel a lot better if I have a shot of an NAD booster in the morning when I get to Australia, which I travel to pretty often. And so I don't know if it's truly working. We need more than one person in a clinical trial. But it fits with the mouse studies, which is that you can use NAD to reset your clock. What's interesting about this is that NAD isn't being driven by the clock is being driven by NAD.
Okay, yeah. So for people that are viewing or listening, the clock meaning the what's regulating circadian rhythm.
Yeah, how your organs coordinate what time of day it is. And when you're jet lagged, your brain might realize that it's morning because your eyesight sees sunlight, but your liver still thinks it's the middle of the night, so you feel queasy, and that's the feeling.
And the reason why NAD is really important for a variety of metabolic, it's required for metabolism, for metabolizing glucose, metabolizing fatty acids, your mitochondria need it, but it's also important for a variety of other tissues as well, activating sirtuins and then DNA repair enzyme, PARP.
Right, you could argue that NAD is the most important molecule in the body, maybe with the exception of ATP, but without either of them you're dead in about 30 seconds. So NAD and ATP were probably the first two molecules that life on this planet used to survive. And it's, to me, and amino acids as well. And so isn't it interesting that the amino acid levels, ATP and NAD are the three main molecules in our bodies that are sensed as to what our environment is like and whether we need to hunker down and survive or go forth and multiply. And those are the three main pathways. There's the sirtuins, there's AMP kinase, which is the metformin pathway, and then there's mTOR, which is rapamycin, which I'm sure you and many of your listeners are aware. But we're tapping into very early aspects of life that's found all over the planet. And that's why I think we're having such big effects in the animals. Often people say it's too good to be true. You tweak one pathway and all this good stuff happens. Well, these are pathways that have existed for going back probably more than 3 billion years. And we're only just learning how easy and seemingly safe it is to tweak them.
So NAD levels decrease with age, and you think this is plays a causal role in the aging process?
Right. So why is NAD linked to sirtuins? So sirtuins are enzymes, and this is my picture of an enzyme, but think of like a Pac-Man that's chewing off chemical groups off other proteins, telling them what to do, like a traffic cop. And without NAD, they don't work. They're stuck shut. And so there's always NAD around, otherwise you'll be dead. But if the levels go down as they do as you get older, and I'm almost 50, so my levels probably are half what they were when I was 20. Scary thought.
Wow.
So my sirtuins are working maybe half as well as they did telling the troops to go out and fix my body. So when I go for a run, I get less benefit from that. I feel tired, I don't make as much energy, mitochondria are down. But by raising up the levels of NAD to when I was young, what I think is going on, based on the animal work we've been doing for many years now, is to trick the body into thinking that it's young again, or it's been exercising or dieting. And that allows the sirtuins to do their job the way they once did.
By just having that level of NAD higher, like it's basically like a signal
It is. So think of it as the fuel in a car if the sirtuins are driving.
Yeah.
And then the resveratrol that we worked on years ago works on the same enzymes, but it's the accelerator pedal.
There's all this other stuff we were going to talk about. You've mentioned these NAD boosters, and we probably should definitely get into that. But
well, they're central too, because as I mentioned, the proteins, many of them, like the sirtuins, who are moving around, controlling the epigenome, you want to stabilize that as best you can. Animals like whales and naked mole rats have a very stable epigenome, so this moving around of proteins and epigenomic noise accumulating. If we're exercising, we're taking NAD boosters, we do slow that process down, I believe.
Well, let's talk about what NAD boosters are. So the precursors for NAD, right?
Sure.
We make NAD in our bodies.
Yeah, we do. And so NAD is recycled in the body because there's grams of it. You can't eat that much easily. And there's a cycle, it's called the salvage pathway of NAD. And it all starts with nicotinamide, which is a form of niacin, vitamin B3. But you can't just, well, you can, but it's not very effective, just overdose on vitamin B3 because you need other things to make the big molecule NAD. So NAD is, the reason it's called nicotinamide adenine dinucleotide is that it's got these three main components. And the dinucleotide is related to DNA, right? But that's beside the point. It's a big molecule so that if you give a big molecule to cells, it doesn't get taken up. So we don't feed animals NAD. And we don't just feed them nicotinamide, which is the little N part of NAD, because it's too small in that you need these other parts. So NMN and NR are two molecules, so it stands for nicotinamide mononucleotide, which is essentially the precursor, the immediate precursor to NAD. If you give a cell NMN, it will be taken up by a transporter, which was just discovered by my buddy Shinamai. We used to work together at MIT, now he's at WashU. A few weeks ago, he wrote about it, I wrote about it, that there's a transporter that sucks up NMN. And the NMN is converted within one step to NAD in the cell. And now it's locked, it's a big molecule, it's locked inside the cell. And that step is carried out by an enzyme, it's got a name, it's called an MPT. And that enzyme goes up under stress and calorie restriction. And in yeast, it's the same step. And so we showed years ago that that step of conversion of NMN to NAD, or in yeast, nicotinic acid to NAD, is the critical step for boosting NAD when you're going through your circadian rhythms, when you exercise, when your cells are stressed. And without that step, you don't get the benefits of calorie restriction and your organs start to get old. So what is NR? So NR is fairly popular. A lot of people have heard of it. It stands for nicotinamide riboside. And all it is it's just a smaller version of NMN without a phosphate on there, so there's no phosphorus on it. So if you take NR, your body has to first put on a phosphorus, and then it has to basically link two of them together to make the NAD. So with all that said...
NR gets converted into NMN first, and then into NAD?
Yes. Yes, it has to, yeah. But NR and NMN have both been shown to raise the NAD levels in animals and in humans as well. And there's small nuances about the differences, but they both seem to be effective. Not just in humans, actually, and I should say in mice, but in yeast, they work as well, which is nice. I suppose people are interested in the plant world and what we eat. These same pathways, these sirtuin pathways, exist in plants as well, and they get turned on in response to stress. We call this xenohermesis, the idea that when we eat stress plants, we get those molecules and they help our bodies. So resveratrol, going back to that old chestnut, it's a grape molecule that is produced when the grapes get stressed. And
it's like fungus, right?
Well, fungus will stimulate it.
Fungus stimulate, yeah. Okay.
Or lack of water. So when they harvest red wine, they hope for a dry season. Mm-hmm. That'll boost the resveratrol levels and other good polyphenol molecules. And I think that when you ingest those molecules, the sirtuins have evolved to sense the plant world, and if your food is stressed out, your body will hunker down and become fitter as a result of sensing that. Because we can see crops that are dying, or if the water table's drying up, maybe we can sense that, but little animals that we evolved from, or even a squirrel, it's too dumb to know that its food supply is stressed out. Its body has to take care of that message.
Yes, so the resveratrol is activating all these stress response pathways that are basically in our we have in our body, and and basically turning on all these genes that are helping you deal with stress.
Right.
But they're like staying activated for longer, and so when basically aging, which is a stress, you're basically dealing with aging better.
The NAD boosters also
Yes.
help the brain. So at least in mice, a couple of labs have published now in top journals like Cell that raising the NAD levels in the brain also improves memory and slows down the advancement of Alzheimer's. In mice, admittedly, I know we've cured Alzheimer's in mice
Well,
thousands of
both
times.
nicotinamide riboside and nicotinamide mononucleotide have been shown to do that in animal studies, right?
Yeah, I'm amazed how
Yeah.
much you know. So that's true. I would love to do a human study. Actually, one of the benefits that we might see is also improved blood flow, and that might be helpful for vascular dementia because, as I'm sure you know, we've shown that NMN and others have shown for NR that it also helps with blood flow and actually mimic exercise and regrow the vascular system. And we've done that for muscle. We've got some early results that it also helped restore blood flow in the brain, which is badly needed for a lot of elderly people.
Right. Yeah. No, that's a big thing for cognitive function, and so NMN was able to do that
In the mice.
in mice. Yeah. That's so with the clinical studies. I've seen a couple with nicotinamide riboside, but I guess the question is with the nicotinamide riboside, there's been a little confusion about whether or not nicotinamide riboside is even really getting converted into NAD inside cells in different organs other than the liver. This was this NAD flux paper that was done by Rabinowitz. Thank you. Yes, that study he recently published just a few months ago, looking at nicotinamide riboside and how orally, at a dose half of what typically is used in all the other nicotinamide riboside animal studies. So typically they do 400 milligrams per kilogram body weight per day. I don't remember how long duration they were doing it, but in the NAD flux study he did 200 milligrams per kilogram body weight, which is significantly less than what all these other studies, like the one you mentioned with Alzheimer's disease, and other studies that have shown improvements in mitochondrial function in mitochondrial mutator mice and also muscular dystrophy and all that. So
we use double that dose as well.
so maybe this NAD flux study that showed nicotinamide riboside given orally didn't form NAD in the muscle, but it did in the liver, could have been a dose-dependent thing.
It would make sense because we've done a lot of this in mice and now in humans, and that there's a threshold that you need to cross. You need to take a certain amount to get over probably the body's clearance mechanisms, and then you get up to a level that plateaus after about 9 days. And they may have just been under that threshold, so the body was just clearing it out. But you have to seemingly overwhelm that clear-out system. So that's why we do at least 400 mg per kg in
And that's
in the
with
mice.
nicotinamide riboside. The question is, that's like if you talk about a human equivalent dose for like a 180-pound man, that's like over 2 grams a day. And it kind of leads me to my next question, which was the most recent clinical study with nicotinamide riboside, where they actually used a much higher dose than the original study that was done with Basis, the Elysium that had pterostilbene in it. This dose was like 1,000 milligrams a day, and they looked at a variety of endpoints in addition to, they looked at endurance, looked at...
It was Doug Seal's study.
Yes, and there was no statistical significance in anything. It raised NAD levels, but there was no statistical significance. There was trending improvement in the vascular system, and there was no effect on endurance. And I'm wondering again, well, if we go back to the human equivalent dose, what was given to the animals, that was still less than half. So the question becomes, is it not even making NAD in the muscle tissue at that dose, or, which brings me to the nicotinamide mononucleotide. Now those studies have been done in animals at a much lower dose than 400 milligrams.
They have, So we in my lab and at the company Metro Biotech, we've been using a whole variety of different molecules and different, we're doing what's called pharmacokinetics. So there's a lot of literature that I could talk for another hour on. One of the big questions people ask me is, have you ever put NR and NMN head-to-head in a study? And we need to do a lot more of those. Typically they're not done. And I'm unaware of it being done in humans at this point. But in mice, what we see, and for all the NR folks out there, please don't be angry, this is just data. I don't run the experiments, I just deliver the message, that at the same dose, NMN will increase endurance. And I forget what that dose was. It might have been 200 or 250.
Yeah, 200.
NMN didn't increase endurance. NR did not increase endurance, but NMN did. We do find that for some parameters, and Matt Kaberlein, who I mentioned earlier, he works on dog aging now after doing his SIR2 extension lifespan. So Matt also has published that comparing NR and NMN, only NMN worked in his disease model, which was a mitochondrial disease, where those animals really need a boost of NAD. So one of the issues could be that NMN is a better molecule in that regard. It could be that maybe the mice just work better than humans and we need a bigger dose. But what I'm working on, which is not talked about a lot because it's in the commercial realm, is there's been a team of 7 chemists working on much better molecules than any of these two that I'm talking about, super NAD boosters. And we have ones that work far better than NMN. And these are timed release, these are what we call prodrugs. And those are the ones that I'm really excited about for medicines of the future that don't just increase someone's endurance, but could actually treat diabetes and heart disease and cancer and Alzheimer's. That said, we are doing a clinical trial right now with a molecule called MIB626. MIB is just Metro Biotech. And that's a couple of clinical trials that have been done at Brigham and Women's Hospital in Boston. Separate group from me, it's all independent. And that's just a safety study. So when I come back on your show, if I come back on your show, I may be able to tell you if we see some actual efficacy, some results. We're going to be looking in the phase 2 study at strength and endurance in the muscle of people after some NMN dosing. So we're on the verge of knowing if this is real or not for people.
Is this the first NMN study that's being done in humans, clinical study that you're doing here, or is?
So we've done a couple, but yes, as far as I'm aware, we're the only ones. Actually, you remind me to say something important for the listeners. Make sure your NR and your NMN is kept in the cold. If it's just on the shelf and it's not in a stabilized form, then it will degrade into nicotinamide, which is something you don't want to take high doses of, because we've shown in my lab many years ago that nicotinamide will inhibit the sirtuins and PARP as well, and interfere with DNA repair.
What? Really? Like
Yeah.
the form that's in vitamins?
Right. It doesn't have a super long shelf life. That's not very well known, so keep it cool.
Wow.
Freezer or the fridge.
But I mean, like if you're buying nicotinamide riboside, from a variety of companies that make it, it's certainly not shipped to you cold. So the question is, how much of it's already degraded just on the shelf?
I don't know.
I mean, it's kind of the case with probiotics. When you get probiotics, you want them to be shipped to you cold.
Yeah.
So that they're live.
Right, same thing here. We have to also replace our mouse NMN. We put it in their water. We replace that every week because it goes off. But that, if it gets wet or gets a bit of humidity in the bottle, it's only a short time before it's degrading.
And we were talking a little bit before the podcast about. I was super excited. I think it was the 2016 Cell paper. You mentioned the group that published the NMN, basically that was given to normal mice.
Yeah, Shinamai study. Yeah.
Shinamai study, that's right. And basically, I think it was about 200 milligrams per day, like that dose, because I remember looking at the dose and going, this is significantly lower than nicotinamide riboside dose. And it seemed to delay tissue aging in multiple organs, where, it was like, I don't know, did it extend lifespan?
He didn't take it long enough. He ran out of material. And in those days, NMN was hard to get, and it was very expensive. It still is very expensive. We're still paying tens of thousands per kilo. But what he showed was that over a year of treatment, pretty much all the parameters of health in these mice were improved. And if those mice didn't live longer, I'd be surprised. But we have done an NMN lifespan in my lab, and it's still ongoing, and it's been crowdsourced funded, so thank you for your donations. But it looks significantly different, the group that's on NMN in their water supply. And also it improves frailty. In other words, they're less frail. Looks like it improves heart function as well. The dose, I can't exactly remember what we're using. It's probably around the 400, which is what's our standard dose, but don't quote me. But yeah, NMN and NR seem to do remarkable things to rodents. But like you say, like you brought up, the challenge is A, does it work in humans, and B, if it does, what dose is necessary to get those effects?
Right, and is there going to be side effects with, like if you read the most recent study, the clinical study where the dose of nicotinamide riboside was like 1,000 milligrams, there were a lot of people that dropped out because they had rashes and I mean, there was flushing. Yeah, there's some side effects. There were some side effects.
It might be with NR. We've never seen anything like that with NMN. And I take a gram of NMN every morning.
But you said, so the NMN is the reason why there are more studies with NR, because NMN is so expensive?
Yeah, well, historically, some companies started making NR early on and made it widely available and cheap to researchers. In fact, so cheap they were giving it away to researchers. So it became used much more often than NMN. But increasingly, and if any scientist lab wants some NMN, let me know. I'm happy to subsidize it if they'd like. But yeah, and NMN was late on the scene because it was harder to synthesize because it's a bigger molecule, needs that phosphate, and phosphate chemistry is quite difficult.